This is just a short video on producing TG&V boards. We've got quite a few to do here, so we've got a tongue on one and a groove on the other side, and each one has a small V, and show you how that works and how we set the machine up to do that. So we're using a spindle moulder, and this is quite an unusual spindle moulder, but I won't talk much about it here because there's another video on the channel. It's the one before this one that shows it you if you're interested. Basically, the spindle is capable of rotating through 270 degrees. Now, that's pretty exceptional for any spindle moulder, and also allows the machine to operate as a mortiser, a tenon, and with a different spindle fitted, which is that one there, can also act as a router and an overhead router because of the degree of rotation possible in the spindle. It does give us a couple of differences in operation when used as a spindle moulder, but not much really. It's pretty easy to get used to. Well, what we've got in here is a head, a cutter head with limiters, and by contrast, here's a cutter head without limiters. So the knives are, the cutting knives are here, and the limiters that go with that pair of cutting knives are here. So in this head here, you've got 4 inserts in total, and the inserts are currently in. I've got the machine switched off at the moment. I've got the power off. The cutters in there at the moment are producing the groove. We've already got the tongue on this board, so we're going to cut the groove on that edge of the board there. And the limiters basically are set so that if anything inadvertently comes into contact with the cutters, the idea is the limiter throws that out of the way before the cutter can do any damage to it. Be that your finger or the odd bit of wood or whatever it is. Now, when we set that up, you need a scrap piece of wood really to run through before you do your main boards. These boards are a little over 6 foot long, and there's a bit of they haven't been trimmed to size, and some of them are, a foot or more too long, and it's just the way they've come out of the stack. They're larch boards, and they've come from the sawmill with their bark on them and in an unplaned state. So basically, I've put these through the thicknesser, and we've cut them, dimensioned them, taken the bark off, and cut them with a rail saw. Now, the rail saw is very, very useful for long stuff and for sheet material. This workshop is too small to handle big stock. We've got a dimensioning saw here, which is a very nice Wadkin saw I sometimes use with a sled, and hence it hasn't got a riving knife on it currently, and I have got a sliding table on that, but I never use it. I think I usually go to a rail saw in the yard to cut anything big, because it's you can do it so accurately and easily, and this workshop just isn't big enough to handle very large pieces of stock, particularly sheet stuff. Anyway, here we are. We've got this one in here. We've got the fences lined up. So the fences need to be lined up with one another. So if I put a straight edge over them, let's see. This is a piece of oak that I just used as a trowel piece to cut the tongue. And what I could do is I could use this to cut the. I've actually used a different piece, but I could use this on the other side to cut that, and then rip it down the middle and put the two halves together to check it's all in alignment. Because even though we're using the same cutter block with that set of cutters to produce the not that set of cutters with it, I've got they're the ones that produce the tongue, and these are the ones that are going to do the groove. Hence the tongue is on this one, and that tongue is going to chop the groove out of that edge of that wood, and the chamfer on the bottom is going to give us half of the V running up that board to match the next one. You can just see it there on the bottom edge of that board. That chamfer is the other half of that V produced by that bit. Now these are numbered, and actually I only had the cutters for this half of the job, because they went with this cutter block here, which doesn't have limiters in it. There's nothing wrong with these, they just don't have that safety feature built into them. And when you use, I mean this one, it's got a beading bit in it, and I use beading quite a bit. Now that's your recommended speed for this particular cutter block. So you'll have probably both those speeds on your spindle moulder. This one runs 3, 6 and 9,000 RPM, and but I can also convert it to 14,000 RPM, but only with that spindle fitted, because that's got an extra gear on the back of it. It's belt driven, but so it's got an extra pulley on the back of it to give me a much higher speed for the router bits. Okay, so we're done with these really, and we're not using that, so I'll put that one away, and we'll just have a close look at this. That's me done there. So the cutter and the limiter are held in place with this dovetail block here, which you do up with an Allen key. Often the Allen keys have that isn't the one for that actually, but I see it here. So it's similar. So the Allen key's usually got a handle on it there. You do those up nice and tight, those hex keys in the middle, and that will prevent them from becoming loose. Do them up as tight as you can with that, because that's sort of calculated to give you the right torque ish. It doesn't have to be exact. And when you put the other set of knives in, you're going to have to alter not the height of the spindle, but the distance of the spindle from the work. Either move it closer or move it further away, whichever one is good. And that's really why you need a reference point when you're setting it up. Like a piece of wood like this, so that if you have to come back to that, you can very easily set it up against that block of wood. You want to make sure really when you're if you put a straight edge in against this, that when that straight edge is making contact with both of the fences there, and it's making contact with the cutting edge of the cutting block, the cutting edge of that cutting block is just going to kiss that straight edge there, but isn't going to push it away and push it down the fence in that direction. That's going to give you if you do that, that's going to give you a bit of an undercut, overcut, a snipe. Let's call it a snipe at the end of the board, so you won't get a straight line all the way down it. So avoid that one if you can, and get it set up properly and check it against this, so you don't have a snipe at the end of the board. I just did have a piece hanging around there, but can't see it. Okay, so we've got this one set at 9,000 RPM. We need this here to come forwards, and in front of that, and I don't want it to be hit by the cutter, but I do want it to press down on the board here to keep the board in contact with the table at all times. So we've got no power, so we can restore that, and now we've got power to the machine, and I'm extracting that, and the extraction is quite important really on a spindle moulder, just as it is with a planer thicknesser, so it doesn't all get bunged up. And I'm pulling it away in this quite powerful extractor here. It's a single phase workshop extractor. I think it's a 3 horsepower motor, and it's got an M-class filter on the top of it, which takes most of the rubbish away. Okay, I'm just going to put this in the tripod. Gloves give you a bit of a non-slip surface there, so that you can propel the work through the machine. This corner is usually drilled out to accommodate a power feed. Power feeds have about 3 rollers on them, rubber rollers, and you sort of angle them in a little bit towards the fence, and push the work down with them, and they're variable speed, so they'll propel the work for you through the over the machine, through the cutter and over the machine, and out through the other end. I've just got this supported on a stand there. Yeah, you know, you just got to try and accommodate the work as best you can in terms of supporting it when it comes out. So that shouldn't be too much of a problem. Now, if we have a look at that, so there's our board, and we put that. Which one did we put through? Put the groove. We put the groove through it, didn't we? It's a big knot in it there. If you can see that, I think you can. But actually, that one was out of it already. So yeah, that one was out of it already. But you know, spindle moulder will knock the knots out if they're sort of. If there's less than half a knot, there's a good chance that it's going to pull it out. And so you need to be wearing goggles as well as ear protection and eye protection with these things. There's our matching board for this one. So they would go together like this. And I can get that one in there. I've got it in there at any rate, and I've got a good joint up there if I just move it on so you can see it, and so that's what we're looking for, TG&V. Pretty simple operation on the spindle moulder. Half the work is really just in setting it up, and that's not a difficult thing to do. One thing I didn't mention is the position of the fences with regard to the cutter. So what we try and do here, just switch that off. What we try and do here is keep the fences as close as we can to the cutter, but leave a 2 or 3 mil at least on that side of it. I mean, a lot of people put sacrificial wooden fences on the over the top of the machine's original equipment, but you know. I don't know. These fences are very good. I quite like them, and they're precise. And you need to check them for squareness, and you can see how the squareness is altered by this Bristol lever here, and the fence is actually released by that one and that one, so you can move it forwards and backwards when you're changing cutters or taking the cutter head off. Etc. etc. These machines all vary a little bit, and people use them in different ways. And for this particular job, a power feed roller would be really helpful. I had one on the last machine I had, but I sold it. It was quite a small one, and I wanted actually. It didn't have a sliding table on it, and this machine does have a sliding table, and you can move these aside and move the table back and forth. It's a really nice sliding table actually, and this Morten's MF30 shares its chassis and sliding table with the circular saw they also make. I don't think they're called Morten's anymore. I think they're now called Wood-Mizer, or Wood-Mizer have either bought them out or you know, they're marketing their machines one or other. But anyway, they're not green and grey anymore. they're sort of orange and grey for what that's worth. Machine is exactly the same as it always has been. Okay, that's it. Thanks for joining us, and please like and subscribe. We're just trying to share a bit of information, and we're desperate for subscribers. It doesn't cost anything, but it helps put the information out there a little more. Thanks, guys. Hope to see you in the next one.